And here we are, the final video of rounding. We are looking at estimation. So by now you should know how to round to significant figures. You should know how to round to decimal places. And all of that's going to come into use as we use estimation. So estimation is something which is really useful. You probably would have very likely used it in everyday life. And examples are time, so how long something takes, what time something will start or finish, how much money something costs. If you have a bunch of things in a basket, how much does it cost? You'd work it out by rounding. The length of something, the distance from one place to another, how much liquid is inside a container, for example, how many liters, and there's loads of other examples here. So estimation is really commonly used. What we're going to look at is a bit more methodical approach, but the nice thing about estimation is you're not expected to give exact answers. That's the whole point. So if you can take away one thing from this topic, that is, do not give exact answers for estimation. Do not try to waste your time working out exact answers. The whole point is estimation. So if you see a question that says estimate and then a calculation, you will get 0 marks if you work out the exact answer. The whole point is to be efficient and to avoid doing too much working out. So there's a balance between being accurate and being efficient. If you're accurate, it might take longer for you to work out the answer. If you're efficient, you might have a rough idea of what something is, and that might be better if you just need a rough idea. So we'll look at this example here. What you have is all the square numbers from 1 squared up to 12 squared. So they're listed in green, and you're going to use this as a rough scale to estimate the following values. So have a look, think about what 7.5 squared would be. So I'll give you a hint with the first part of this question. You know that 7 squared is 49 and 8 squared is 64. So 7.5 squared would go around here. So roughly it's going to be somewhere between 49 and 64. So what do you think it is? Do not use a calculator. That's the whole point, is you're estimating. So roughly speaking, what would you think it is? I'm going to do it along with you, and I haven't looked at the answer here. So I would say that's basically 50. That's about 65. So I'm going to say 56 is my guess. So I'm going to I would estimate that to be about 56. And then the exact answer is actually 56.25, so I was very close. Now, you may have been off by 1 or 2. You may have said 54, 55, 56, 57, 58. In a real test, in a real exam, if you were asked to estimate this, then you're allowed to be off by a bit. So if you said 55, you would have still got full marks. If you said 57, you would have got full marks. 56.2, that's also fine. 57.3 would have been fine. So I can't give you an exact upper and lower limit, but you should just know that for this topic, this is generally how we approach it. So have a go at estimating 2.9 squared. Where would that be on here? What would you think the value is? And then I'm going to have a go as well. And then we're going to figure out what 2.9 squared roughly approximates to. Okay, so I'm going to have a go now. So we know 2 squared is 4 and 3 squared is 9. So 2.9 is quite close to 3. So 2.9 squared is going to be quite close to 9, but slightly less. So I'm going to say that this will estimate to 8.9. I'm going to say 8.7. Now let's see what the exact answer is. The exact answer is 8.41. So in a real test, I would have got full marks with that, and I would say anything between 7 up to 8.9, yeah, I would probably be accurate enough, or as an estimation. 6.9 squared, what would you say this is? Take a moment to work this out. Okay, so 6.9 squared. So 6 squared is 36, 7 squared is 49, 6.9 squared would be closer to 49 than it is to 36. So I'm going to guess 48.2. 48.2. Let's see what the answer is here. The answer is 47.6. So that's a good estimation. I'll be curious to know what you estimated it to. And 11.1 squared, what will that estimate to? Take a moment to work that out. Okay, so 11.1 squared. So 11 squared is 121, 12 squared is 144, 11.1 is very close to 11. So it's going to be a number close to 121. So if you guessed around there, that's good. It has to be bigger than 121 because it's 11.1, not 11. So I'm going to say 123.2. And the exact answer is 120. Oh, that was very, very close. So if you get, for example, 121.5 up to 123, 124, 125 maybe, then you would have got full marks with that. So this is an idea of what it means to estimate something. Now in a test you may not be given all the square numbers, you would just be expected to know what the square numbers are and use these as a kind of rough idea to estimate what the values are. So let's do another example here of square roots. So this time we know, for example, the square root of 36 is 6, the square root of 49 is 7, the square root of 81 is 9, and so on. So let's work backwards and say, what would we estimate, so roughly the value of the square root of 111? What would that be? Take a moment to look on this scale. Where would it belong and what would that go to? Okay, so I'm going to have a go now. So 111, so we know the square root of 100 is 10. So the square root of 100 is 10. The square root of 121 is 11. So the square root of 111 is going to be somewhere in the middle of here. So I'm going to say 10.5 is my estimate. It might not be exactly in the middle, but 10.5 because it's roughly halfway between this. So let's say 111 would belong roughly halfway here, so halfway there would be 10.5. I'm not going to go higher or lower than that. So the correct answer is 10.53, 10.5356, and so on. That's been rounded off there. So roughly this value would have been a good guess, anything around 10.5. As you can see, I'm just estimating these. I haven't looked at the answers, but I've managed to get quite close, and you'll get better at this with practice if you're not close already. So the square root of 55, have a think, pause the video if you need more time. I'm going to work out what I think the answer is. So 55 goes here. Now 55 is closer to 50 than it is to 64. So it's going to be closer to 7 than it is to 8. So I'm going to say 7.3. So 7.3. And I can tell you the exact answer is 7.416. So that's very close. That's a good estimation. All right, let's try another one. The square root of 11. Have a go at working that out. Okay, so the square root of 11. Now I know that 11 would go here. If you imagine this is a number line, goes from 9 to 16. 11 would be closer to 9. So it's closer to 3 than it is to 4. And I'm going to say 3.2 is my estimation. So the exact answer is 3.3166. So again, good estimation. Hopefully you're also having a go at this, not just watching the video without trying the work. So here, the square root of 37, the last one for you to practice here. What is the square root of the estimate for the square root of 37? So let's have a look here. 37. Now we know that actually this is going to belong here. It's very close to 36. So on this scale here, it's going to be very close to 6. So I'm going to say 6.15. and I'm curious about what you would have guessed. So somewhere around there would have been sensible. The exact answer is 6.08. So there we go. So this is just getting you used to the idea of estimation. So next question, what I want to do is go back to significant figures. So the previous videos in this playlist, you would have rounded to significant figures. Have a go with all of these questions, and then I'm going to show you the answer in 5 seconds. Okay, 5, 4. Okay, here come the answers. So 4092, when you're rounding to one significant figure, the first significant figure is 4, so you're rounding to the nearest thousand. The decider is 0, so you're going to round down. This would be 4,000. Question 2, to two significant figures. So here's the first significant figure, it's the first non-zero digit. The second significant figure is 0, and the place value of that is 100, so we're rounding to the nearest 100. The decider is 2, so we're not going to round up, so this will be 8,000, not 8,100. If that number was a 5 or above, then we would have rounded up. Okay, question C. We have the first significant figure is 5, and the second significant figure is 8. And we're going to round to second significant figure. So the place value here is, that's tenths, hundredths, thousandths. So rounding to the nearest thousandths, or something in the 0.001 times table. So because the decider is 2, then we don't round up, so it's going to be 0.058. And then finally, the last question. So the first significant figure is 7, second significant figure is 0. So we're rounding to the nearest 0.1. The decider is 4, so we don't round up, so it's going to be 7.0. And that 0 is very important. It's not just 7, it's 7.0 because we rounded it to two significant figures. Okay, so this was just a recap. You may already know this. If you don't, you need to go back and watch the videos on rounding to significant figures, because we're going to use this skill now with estimation. So estimate the following things. Now, because it's a video, I'm just going to show you all of the questions in one go, so you can pause it and have a go, and then I'm going to tell you what the exact answers are. The point of this is not to work out the exact answer. Remember, that word means you are just sensible guessing, not random guessing. Just have a sensible guessing. Use your knowledge and common sense here. Okay, so I'm going to go through the answers now. So you should have a list of answers here. So number of students in year 8. So roughly it's going to be 168. So that's how many there are in every year group. Number of students in the school. So I looked this up. It's actually 1,180. So we're including sixth form. Amount of people who are left-handed. So roughly 10% of the population is left-handed. So we would expect 10% of 1,180. So something like 118 students. Number of teachers in our school, so roughly that's going to be 110, could be more than that. I don't actually know the exact answer to that. The number of fans Mr. Mathwana had, well, that number doesn't go as high enough, so it's just going to be about around infinity if you round it. The population of London, so you may already know this, it's roughly 8.7 million, 8.8 million, so you could say it's about 9 million. The population of the UK, you might know this from geography, so it's about 70 million. And then the amount of time you spend looking at your phone screen in a day. You might have an app that tells you this, but this is going to be subjective. It's going to depend on you and how addicted you are to your phone. Okay, so let's look at a key way of representing an estimation versus a calculation. So if you were asked to work out 2.9 times 5.1 and you worked out the exact answer, however, maybe with a calculator, maybe by doing long multiplication, then this is called what you already know. It's called exactly equal to, and we use this symbol here, which you're used to. It's just the equal sign. Now, if you are estimating the answer, so if I said to you, what is 2.9 times 5.1, roughly, you probably would in your head do 3 times 5, and that would give you 15. Now we know the real answer is not going to be exactly 15, but roughly it would have been 15, and that's where we use this symbol here. And this symbol, it means approximately equal to. So it's just a wavy equal sign, and it means approximately equal to. And we need to be careful to use that. You should not be using an equal sign here because it doesn't equal 15, it's approximately 15. Okay, so make a note of that in your book. Approximately equals to and exactly equals to, and in the next video we're going to do some practice using this notation and then doing some approximations. Smash the like button, hit subscribe. See you in the next video.